Hello everyone and welcome back to Math Channel. We're still talking about the mass conservation equation, and I'm gonna show you a real example and not relate to a swimming pool. I think it is a good way to understand the sign of the divergence of a fluid too. So we have a pool, at the bottom of it, there's a hole allowing the water to come in the area or to leave it. Let's have 2 points. P1 in omega 1, P2 in omega 2. Omega 1, divergence of V is positive, whereas in omega 2, divergence of V is negative. Sign of the divergence term gradient applied to V in the mass conservation equation does not imply an increase or decrease in the real mass of the control volume. Instead, it represents the local rate of change of mass density. In the first case, omega 1, when the divergence is a positive quantity at a particular point within the control volume, it implies that there is a net inflow of mass into that point, which seems fair looking at the water passing through P1. So we have more and more water filling up our swimming pool. This means that more mass is entering the control volume to its boundaries than is leaving it, which leads to an accumulation of mass within the control volume over time. Conversely, in the second case, omega 2, when the divergence term is negative at a point within the control volume, it indicates a net outflow of mass from that point. This means that more mass is leaving the control volume to the boundaries than is entering it, resulting in a reduction of mass within control volume over time. You can see here the water is leaving the area passing through the green point. Why do we say that the sign does not imply an increase or decreasing the overall mass of the control volume? Because in this example, we're looking at the problem locally, only at one hole. For instance, there could be multiple holes with water coming in and out. So we don't know the overall behavior of the total volume. Our example is not meant to be a general case. In summary, the positivity or negativity of divergence ρ indicates the net flow of mass into or out of a specific point within the control volume, rather than directly implying an increase or decrease in the overall mass of the control volume. And that's the end for today. If you have any questions or would like to see more about this subject, just note in the comment below. Until next time, happy schooling.